Hey guys, let's have a look at this week's assessment number 8, which consists of perimeters and areas, composite areas, metric conversion, including converting units of area, and a start to probability and expectations. Now, if this is your first time through this, or if it's been a while and you're using this for practice, feel free to hit pause at any time to try these questions for yourself, and then we'll take them up at the end. Question 1, perimeter, area, and metric conversion of both perimeter and area. Again, perimeter and area, and converting units of area. Next, we have perimeter and area again, along with metric conversion. Perimeter and area of composite shapes. Perimeter and area of composite shapes again. Note the markings. Theoretical probability. And probability and estimation. Right, let's get started with taking this up. First, perimeter, area, and metric conversion of both perimeter and area. I'm accentuating the fact that this is for both perimeter and area. To convert the units of area is not the same as converting units of length. For question A, we're looking for the perimeter of this rectangle, which is 2 lengths plus 2 widths. And for part I, we want to do this all in centimeters. Notice that I was given this length here in meters, so I'm going to need to convert that. Now I'll do the perimeter, which is 2 times the length in centimeters, so that's 140 centimeters, plus 2 times the width, which was 52. And that gives us 280 plus 104, that's 384 centimeters. Now, I can work out the perimeter in meters just by converting the centimeters directly to meters, or I can have a look at the length and the width that I was given, convert those values first, and then work out the perimeter. So that's what I'm going to do first. The perimeter is equal to 2 times the length in meters, so 2 times 1.4, plus 2 times the width in meters, so 2 times 0.52, which gives me 2.8 plus 1.04, which is 3.84. Now notice we are converting perimeters from centimeters to meters, so we just use the normal conversion from centimeters to meters. We just need to divide by 100, so move your decimal 2 places. So it shows that we can do that both ways, just like this. To work out the area of the rectangle, we do need to work in the correct units of measure. So for centimeters, we're going to work out the area, which is length times width, using the centimeter length, 140, and the centimeter width, 52 centimeters. Multiply those together, we get 7,280 centimeters squared. Because we calculated that using centimeters, our answer is centimeters squared, because there's square units because we're talking about a 2-dimensional space, the area. For the area in meters, I don't want you to convert this directly from centimeters to meters, since you've got the option to work with the meter measurements here, the meter length and the meter width, to work out the meter area. So let's go through that process. The area is 1.4 meters multiplied by 0.52 meters, that is 0.728 meters squared. I wanted you to do it that way because I know the mistake that we're going to make. We're not used to converting units of area here, so too many people are saying centimeters to meters. We divide by 100. You move your decimal 2 places, and you say that that's 72.80. Now that's not correct. Let's look at how we convert units of area again. To convert from centimeters to meters, we divide by 100. But to convert from centimeters squared to meters squared, we divide by 100 squared. For 2-dimensional areas, we have to divide by the scale factor repeatedly 2 times. That's not dividing by 200, that's dividing by 100, and then 100 again. That's dividing by 10,000, which is why, looking at our answer up here, our decimal has moved 2 places and 2 more places for a total of 4 places, putting that decimal in front of the 7. Next, again, we have a perimeter and area question and metric conversions of areas. But to start out with, they have given us the perimeter. They've told us that the perimeter is 9.2 centimeters. So we are asked to work out the length of the sides of this square. So we'll start by writing the formula, which relates to the given information. The formula for the perimeter is 4 times the length, because of course this is a square. The length, the width, and the width, they are all the same. They're all lengths. So 4 lengths must be equal to 9.2, the given answer for the perimeter. The reason we did that is so that we can rearrange that equation to find out what L is on its own. So 4 times L gives us 9.2. L on its own would have to be 9.2 divided by 4. The opposite of multiplying is dividing. So that means L is equal to 2.3 centimeters. So we've got our length, it's 2.3 centimeters. To work out our area of this square in centimeters squared, we will use the length in centimeters, and we'll do length times width. Now, because this is a square, the width is the same as the length, so that's going to be 2.3 times 2.3, which gives us an area of 5.29 centimeters squared. We have just gone over how to convert units of area, but it's safest to first start by working it out using the length, but converting that first to millimeters. So we're going to do the area is length times width, where 23 is our length in millimeters, and 23 is our width in millimeters. So it's going to be 23 times 23, which is 529 millimeters squared. Now I know what some of you will have done is you will have said centimeters to millimeters, we just need to multiply by 10. But this is areas. These are two-dimensional measures. This is centimeters squared to millimeters squared. We need to multiply by 10 squared. That is not multiplying by 20, that's multiplying by 10 and multiplying by 10 again. 10 times 10 is 100. So look at our answers. 5.29 was multiplied by 10 and 10 again. My decimal was moved 2 places. Same as multiplying by 100 to make 529 millimeters squared. Next we've got perimeter, area, and metric conversion again, but this time it's not converting units of area, so this one should have gone a bit easier. Here you are given the area of the rectangle and the width of the rectangle, and we need to work out its length. Once again, when you are given some information about a shape, when we're given its area, we should start with that formula. So given the area is 4.8 meters squared, we'll start with area is length times width, which means that length times width must be 4.8. Now, as I said, we know what the width is, it's 2.5, and we know that the area is 4.8. So we've put those into the formula, and we just need to rearrange to find out what the length is, what L is. Okay, so rearranging this, L is being multiplied by 2.5. So to get L on its own, we need to do the opposite. We will divide by 2.5. 4.8 divided by 2.5, that is 1.92 meters. Remember that we were given the area in meters squared. We were working with a width in meters, so our length will be an answer in meters. Now that we've got the length and the width, we can work out the perimeter. Setting out the perimeter formula, remember that perimeter is 2 lengths plus 2 widths. So that in meters would be 2 times 1.92 plus 2 times 2.5, which makes 8.84 meters. To convert that to centimeters, we could go directly. We know that to go from meters to centimeters, we just times by 100. And perimeter is a one-dimensional measure, not two-dimensional. But let's go through the process again from the beginning, working with the given values, but converted to meters. So our length, which we worked out here, 1.92 meters, would be 192 centimeters. And our width, which was 2.5 meters, would be 250 centimeters. In both cases, we're just timesing by 100. Working that out, we've got 384 plus 500, which is 884 centimeters. So here, converting units of measure for perimeter should be no surprise. It's not like areas, it's not a two-dimensional measure. We know meters to centimeters, we times by 100, and that's what we need to do. Next, we've got a perimeter and area of a composite shape. The composite shape is given here, but we are missing some side lengths. So to work out the perimeter, we're going to have to work out what this length is first. And that vertical length should be compared to the other vertical lengths. The whole height of the entire composite shape is 9 centimeters, while this bottom part is 4 centimeters. If we do 9 and we take away the 4 that we've already got down here, we should be left with 5 centimeters, that last side. And across this bottom horizontal length, you should compare that horizontal length with the other horizontal lengths on this diagram. This is 2 centimeters, and this is 7 centimeters. 2 plus 7 makes a total of 9 centimeters across the bottom. So we can work out our perimeter now. It's just adding up all of those sides, starting with one side and working away clockwise around the shape. We've got 2 plus 5 plus 7 plus 4 plus 9 plus 9. That gives us 36 centimeters. To work out the area of this shape, we're going to need to break it down into shapes that we can easily recognize and have formulas to work the area for. So there I've split it into rectangle A and rectangle B. Now I could have split it across this way as well over here, but I've chosen to do it this way because I can clearly see what the length and width of A is. They were given 2 and 9. And I can clearly see the length and width of B, 7 and 4. So I didn't have to worry about if I made a mistake down here or if I made a mistake up the side here. I've got the length and width that I need. So for the total area, I'm going to look for the area of A, and I'm going to add that to the area of B. Area of A is 9 times 2, and the area of B will be 4 times 7. So that's 18 plus 28, which gives me 46 centimeters squared. Remember to look at the units of measure. In the question, I've been calculating with measures in centimeters, so my area will be in centimeters squared. Next one, we've got another composite shape here, and it's an interesting looking one. Notice all of these lines all over it. That means that they are all the same length. So when we're told that the perimeter of the shape is 180 centimeters, that means that if I added up all of these sides, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 sides. They are all the same length. All 12 of those have to add together to make 180. So I said the perimeter is 12 of these lengths, and 12 of these lengths equals 180. To find out the length of one of these sides, we're just going to have to divide the 180 by 12 to get the L on its own. Opposite of multiplying by 12 is divide by 12. So L will be equal to 15 centimeters. Now most of you, I'm sure, got that right. But the area of this composite shape, again, just like we did before, we'll need to split it down into recognizable shapes. So I've done this. I can see that I can split this plus sign shape into various rectangle shapes. And if I look closely, I'll notice that those rectangle shapes aren't rectangles at all. They're squares, because I've got this side which is equal to this opposite side. I've got this side which is equal to its opposite side. All 4 sides will be the same length, and we've already worked out what that length is. It's 15. Not only are these squares with all the sides equal, they are all the same size squares. All of the squares are equal. So I've got A, B, C, D, and E. The total area will just be 5 times the area of one of those. So if I were just to work out the area of A, for example, length times width, I know that length and width are both the same. They're both 15. And I need 5 of those because B, C, D, and E are also the same shape and size. So 5 times 15 times 15, that gives me 5 times 225, which is 1,125 centimeters squared. Next, we're getting into probability here. Just basic probability to start with. This is theoretical probability. If Amy has a bag with 3 green marbles, a diagram might help, and 1 red marble, and 6 blue marbles, and Amy reaches into this bag without looking and just chooses 1 marble, Work out the probability that the marble she chooses is red. Well, the probability that it's red is 1 out of how many marbles are there altogether? What fraction would that be? 1 out of, that's 10 marbles altogether. 3 plus 1 plus 6 makes 10. So the probability that it's red is either a fraction of 1 over 10, or if you convert it to a decimal, that's 1/10, 0.1. What about the probability that she chooses a green marble? Here are her green marbles. There are 3 of them. So the probability that she chooses a green marble will be 3 out of all of the possible choices she's got. She's got 10 possible marbles that she could have chosen, and 3 of them are green. So the probability that she chose a green is 3 out of 10. Or, as a decimal, that's 3/10, 0.3. Now read carefully. What's the probability that the marble she chooses is not blue? Not that it is blue, that it's not blue. And you should see from my diagram here, that means that it's either red or green. So I could add these two colors together. I've got 1, 2, 3, 4 beads here, 4 marbles that are not blue, out of a total of 10 possible outcomes, 10 possible marbles. So the probability that it's not blue is 4 out of 10, or as a decimal, 4/10, 0.4. Notice I did not put this in blue here while I put this in red and this in green. This is not blue, any color but blue. Right, some more probability and estimation here. There are 35 people in a park. How many of them would you expect to have been born on a Tuesday? Remember to work out our expectations. We base that on some fraction of the number of possible outcomes. I don't expect everybody to have been born on a Tuesday. I also don't think nobody was born on a Tuesday. What fraction of the people do I expect to be born on a Tuesday? That fraction I would use as being the probability. What's the probability that you were born on a Tuesday? There are 7 possible outcomes. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And Tuesday is one of those possible outcomes. So the probability you were born on a Tuesday is 1 out of 7. So we would expect 1/7 of all of the people in the park to have been born on a Tuesday. So 1/7, that's 5 people. We expect 5 people were born on a Tuesday. Question 8, the probability of rolling a 6 on a biased die is 0.3. So this is no longer theoretical probability because the die is not equally likely to land on each of the different numbered faces. We're told the probability. It's 0.3. What's the probability that it doesn't land on a 6? So it lands on any other number. What you need to remember for this is that there are 2 possible outcomes. If you simplify it down, either you get a 6 or you don't get a 6. That is, you get anything else. And these 2 possible outcomes cover all possible outcomes. You can't get anything other than a 6 or not a 6. That's anything that you could do. So probability of getting a 6 plus the probability of not getting a 6 will always add up to the total probability, which is 1. Knowing that the probability of rolling a 6 is 0.3, we would say that 0.3 plus the probability of not rolling a 6 would have to add up to 1. So the probability that you don't roll a 6 on its own would be equal to 1 minus the 0.3. See, I got my probability of not rolling a 6 on its own there algebraically, and that gives me a probability of 0.7. And our one last question, kind of a bonus question really, but I wanted to see who was paying attention because I got all sorts of funny answers here. My unicorn. Remember the video that we watched about my dog and whether or not she would turn into a unicorn? Well, I did tell you her name, and it was not Rosie. I like this name. Being a mathematician, you thought I chose an algebraic name. I called her N for name. No, it's not N. It's not Sally either. No, not Peter. Not Fluffy, nor Sammy. I like that one too, Pythagoras. Matrix, I might need to adopt another dog and name her Matrix. Isosceles, no, it was not isosceles. Someone even said I didn't have a dog. I clearly have a dog. Maybe that person thought my dog had turned into a unicorn. No, my dog's name is not Miss Danielson's dog. What's my dog's name?